All right, welcome back. Our next step is to talk about how we go about selecting a sample from our population. It's really important to note that when you look at a research study, the way in which they sample has a very significant impact on the validity of the outcomes of that study. We have 4 methods of sampling that we're going to talk about in this video, but it's important to say that not one of these is really better than the other. It really depends on the size of the population that you're dealing with and the type of questions that you're looking to answer. As a quick example about sampling, if I wanted to sample how generally people feel about me personally, but I chose from a sample of the entire population of the world, my friends and family, that would be a very skewed data set that we would get from that sample. But again, importantly, in choosing the method with which we will sample, we need to think about the resources we have, the population, and what kind of answers we're trying to tackle. First and foremost, we have the method of random sampling. This is the way of sampling in which every member of a population has an equal chance of being selected. This is excellent, and this has a very strong validity to this sample group because it's completely random. The issue is if you have a massive population like the population of the United States, it's very hard to create a method of sampling the 300+ million people that live in the United States and giving each member of that population an equal chance of being selected and included in the study. That said, if you have a very small population, what you could do, for instance, is put everybody's name in a hat and choose 10 of those names at random by pulling them out of the hat. In that case, if everything is held valid, you would have a random sampling of that set. But again, that would only work for a very small population. Within the concept of random sampling, there's a stronger version called simple random sampling. And what that means is that every sample size of set n individuals has an equal chance of being selected. The nuance can be a bit difficult to understand, but just to repeat it, random sampling is that each member of a population has an equal chance of being selected. Simple random sampling means every sample size of set n, so every set of 10, a sample size of 10 of a given population, any combination of 10 individuals from that population has an equal chance of being selected. Now again, in large populations, it might not be possible to do a random sampling or a simple random sampling. We could use a method of stratified sampling. In this case, what we do is we separate the entire population into non-overlapping groups, which we call strata, or singularly we call a stratum. And then we take random samples from each group. Again, to use the example of the population of the United States, maybe what we could do, but to separate individuals into groups, we could separate the whole entire population of the United States into the individual states. So we separate into those groups, the 50 states of the United States, and then we choose a random sample from each of those 50 states. Importantly, when we're doing stratified sampling, there's no statement about each of these groups being equal size. So there's an important concept within this, which is proportionate stratified sampling. And what that means is that we take the same proportion, we sample from each of these groups proportionately. Meaning, for instance, if we were looking at, say, Wyoming and California, and we knew California had twice, or say 10 times the population of Wyoming, which is probably more accurate, then we would take 10 times more individuals from the population or from our sample of California than we would the sample of Wyoming. Another method of sampling is systematic sampling. In this case, what we do is we take every kth individual from a population. This would require us in some way to number everybody in a population, if this is a population of people, and select every 5th or every 10th person. When we do this, it's important we don't start with the first person every time. That would lead itself to some bias in choosing that first person and how we decided who that first person would be. So if we're going to choose, for instance, every 10th person, the first person we choose to start our hops of like every 10th person would have to be chosen a random person from 1 to 10. And finally, we have cluster sampling. Cluster sampling is selecting all individuals within a randomly selected group. It can be a bit confusing at times to understand a little bit of the difference between cluster sampling and stratified sampling, because in both cases, we're separating the population into these groups. But just to speak to this difference real fast, in stratified sampling, what we do is separate the population into groups, but then within each group, we take a random sample out of each of those groups. In cluster sampling, what we'll do is we'll separate the population into all these groups, and then we randomly select one of those groups. Again, there are strengths and weaknesses to each of these versions of sampling, really depending on the population size and what you're analyzing. For instance, a good example I think of using cluster sampling was, let's see, if a school was looking to figure out what was the experience of students in their online classes. One way they could use cluster sampling is to think about all of the possible online classes. So they have all of these online classes, which are these groups of this population they're looking to analyze. And they could take everybody from one of those online classes and survey them on their experience in their online class. But again, maybe that's biased in some way because that one individual teacher or the structure they create in the classroom could really bias those results if you wanted to generalize for the entire population of the students' experiences in an online class. So I would think maybe in that instance, it'd be better to do a stratified sampling where you separate the population of students into these classroom groups, but then within each of these classrooms, you take a random sample of the students in each of those classes. And in that way, maybe, depending on what you're looking for, you could get a more unbiased or a more valid data set. There's one more type of sampling that we're going to talk about, but we're definitely not going to encourage, and that's called convenience sampling. This is generally frowned upon, and what this is, it's just an easily obtained sample, not based on randomness. Often when folks are trying to get introduced to statistics and do some research, what they'll do is something is stand outside of a classroom or stand on a street and just take anybody that comes up to them. But really important to this conversation is this idea of self-selection. If you have somebody standing on a street corner with surveys, the types of people that would even consider approaching that person or being willing to engage in the study are self-selected. There's certain kinds of individuals that would do that and not do that. In that case, it's definitely not random. It's important to say too that for large populations that are being researched and you want to do some statistics on, you could do a multi-stage sampling technique where you do one of these and then do another. So in some case, what you could do is take the population of the United States and then do some form of cluster sampling to individualize that to, let's say, a state. But within that state, you're going to do some kind of systematic or stratified sampling that often will happen in large, robust data sets. But it's important to say at this point, we're just introducing this concept. As we collect data, it's really important to be careful about how we select the sample from the population. Here are a few examples. And again, generally speaking, one's not better than the other. One might say, well, random sampling or simple random sampling is the best way, but often that's not realistic in that situation. But in order for the results of your research to be valid, you'll have to think about the way that you're creating the sample from the population. And again, depending on the context and what kind of research you're doing, one or many of these methods might be useful in getting a really nice, valid, unbiased sample. This is related to a bigger, more complicated conversation about bias within research. We're not going to go deep within this, but what I do want to say again is the sampling method is important, but also the size of the sample. If you have 300 people in your population and your sample size is 3, we'll all just get a strong feeling that it isn't going to be very valid to ask 3 individuals out of a set of 300 to represent that 300. So sample size is important. Questions can have emotion to them or be leading in some way to try to get people to answer in certain ways. Or generally the sample that you take out of the population, even if you try to do it in a random way, may not be representative of that population. Also involved in this discussion of bias or within the results that come from a statistical study is this conversation of causation or correlation. And we don't need to get too deep on all these things, but I just want to make sure you are understanding and think of these, and we'll talk about these as we move through the course. But importantly, causation is this thing makes this happen, right? Often what we'll find in research is that things are correlated, is that when this event happened, this event seems to happen also. And what some people will do then is say, well, that means that this event causes this event. And while there might be some link or in some way they do influence each other a little bit, maybe there's many other variables that are impacting those two things, or maybe there's no causation at all. There's just a correlation from other variables that are affecting the things that are happening. The purpose of this discussion is that when you go in to investigate something about a population, you have to be very careful about how you pull that sample. Because even unconscious bias you have in your sampling technique could be present unless you use one of these kind of randomized or systematic methods of sampling. It's also going to be very important the way in which you ask questions. You need to think about questions that you're going to put on a survey or what you're going to research, but you're going to have to also think, are there things that I could be doing personally as a researcher that are influencing the data that I receive?